4.2, combining functions algebraically. So we talked about in 4.1 how to do it graphically, and then I kind of showed you that's most of the algebraic way. An algebraic way is just actually way easier. So let's say you start with two functions. You got f of x equals 3x plus 4, and you have g of x equals x minus 4. And both of these are linear, but it doesn't really make any difference whether it's quadratics, linear, anything like that, or even roots, absolute values, anything like that. So now this, when we write it this way, f plus g of x means f of x plus g of x. So it's f plus g, just a shortened version of writing this. So all we do is we take the two functions, f of x, which is 3x plus 4, and x minus 4, which is g of x, and combine them together. So 3x and x is 4x, and the 4's just disappear, so the combined function is 4x. F minus g of x just means f of x minus g of x. So you take the two functions again, subtract them. Now be careful with the subtracting, because that negative applies to both these things, right? So it's 3x minus x, which is 2x, but it's 4 minus negative 4, which is plus 8. Right? Careful of that. That's a common mistake there, is to forget the negative applies to both. F dot g of x just means f of x times g of x. So we take the two functions. Now here we have two binomials, so when we multiply them together, we use FOIL, right? First outside, inside, last, and we end up with our trinomial. So we end up with a quadratic in this case. Not that difficult. F divided by g of x just means f of x divided by g of x. Now, so there's the two functions. Now you got to be careful when you're dividing, though. We have to talk about restrictions. So in this case, because we have a binomial on the bottom here, we have to be careful of what value of x is. So we can do this, we can graph this, but x cannot be 4, because if it's 4, it makes it 0 in the denominator, which makes it undefined. Okay, flip page, go to example 2. So we got another two functions here. F of x is 2x plus 2, linear, right? And we have g of x, which is, root of 3x minus 2, right? And that looks slightly different. So this one is a little different. So we have f of 3 plus g of 3. What that means is you take the function f, and wherever you see an x, you replace it with a 3. And then just do the same thing with g. You can get questions like this where you actually have to plug in the values and do the math. So here's our first linear, the 2x plus 2. We replace x with 3, right? 2 times 3 is 6, plus 2 is 8. And then over here we have 3 times 3, right? Minus 2, which is root of 7. So can you do anything with 8 plus root of 7? No, that's the actual answer, 8 plus root of 7. Okay, what about this one here? We have f minus g of 0. That means, again, remember this is a slightly different way of writing it, but it means f of 0 subtract g of 0. So you plug 0 into that one, you plug 0 into that one. We do this, we get 2, and then minus root of negative 2. Well, that's kind of weird. Can we do that? No. No answer, because you cannot take the root of a negative number, right? You haven't learned that yet. That's in university math when we're coming up. So this one, you cannot get an answer to it, so there's no answer to this question. So this is just a matter of, right? So go back to the original page here. Take the functions. Just either add, subtract, multiply, and divide. Don't be very careful when you divide, because you're going to end up with maybe a non-permissible value. And then this one is just taking the functions and plugging in numbers and doing the math. Now, in the next lesson, which is a combined 4.3, 4.4, we're going to talk about restrictions when it comes to functions, and you'll see that right away.